All right, so we talked about how to graph linear inequalities last time. So now we want to add that into our systems. We've been talking about systems of equations and how to solve those guys. And systems of equations, there are three methods. Remember, graphing, substitution, and elimination that we need to be able to use to find the solutions for those systems. For a system of inequalities, fortunately, there's only one method to solve those, and that's by graphing. So the idea here is for you to be able to solve systems of linear inequalities by graphing. And then we do want to try to fit this into some real-world situations, right? All right. There are your standards. Take a look at those if you want. Now, just to recap a little bit, how to graph a linear inequality, right? Remember, linear means line. We're going to graph a line. We've got two variables usually in this inequality. So take a couple seconds and just quickly sketch out the graph of these single inequalities, just as a quick review. I'll give you a second. You can stop the video, try them out, and then bring it back up. Bring the video back up when you're done to check to make sure you've done it correctly. Okay, this is what it should look like. All right, first one's going to have a solid line because it's equal to. Okay, and if we were to plug in 0, 0, 0 is not greater than 3, so that's why we're shading away from 0, 0. Second one, dotted line because it's not equal to. X is the only variable you see. So if you remember Vux and Hoy, Vux means we're going to draw a vertical line at -5. And again, if you plug in 0, 0, 0 is greater than -5, so we're going to shade towards 0, 0. The trick with the third one, we had to get it in slope-intercept form. We had to add 2x to both sides, which would give us 2x plus 6 on the right-hand side. Then we have to divide through by -1, switching this inequality sign, and also switching the signs on the right-hand side. Okay, and then we graph that using our slope and y-intercept. Plug in 0, 0 here. 0 is less than -6. That's not true, so we're going to shade away from 0, 0. And of course, we're looking at a dashed line because it's not equal to. All right? All right. So if we remember that, getting into a system isn't a whole lot more complicated. Just in how we show the solutions does it get a little tougher. So we're going to graph the first inequality. So we're just going to graph these guys individually. But we're not going to shade them individually. Okay? And I'm going to show you why. To graph this first one, its y-intercept is -2, so we go here. Slope is 2, so we go up to right 1, up to right 1. Or we can go down to left 1, down to left 1. And then we're going to draw a line. Now, is it solid or dotted? And as I draw this, I'll let you think about that. It's not right. Okay? It's not equal to, so it does need to be a dotted line. Now, where are the solutions for this thing? I'm still going to plug in 0, 0 to find out where the solutions are for this first inequality. So plug in 0 for y. If I plug in 0 for x, 2 times 0 is 0. So we get 0 minus 2. Or 0 is less than -2. Since 0 is not less than -2, I know that I would normally shade all the way over here, but I don't want you to shade. Oh, sorry. Since 0, 0 is not a solution, we'd actually shade this way, but I don't want you to shade. Okay? Instead, what I'm going to do is I'm going to draw little arrows here that will remind me where these solutions are. Because those are just solutions for the first inequality. If we're talking about a system, what we need are those points that satisfy both inequalities. In a system, we have to find those ordered pairs that are solutions for both inequalities. So now we got to go find out where the solutions for the second inequality are. So we need to go to 6 on the y-axis. Then we go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1, since the slope is -1. Draw your line. Just like so. And dotted or solid, it's going to be a dotted line again because it's not equal to. Okay? Now, where are the solutions for the second inequality? They are, well, we got to plug in 0, 0, 0 for y, 0 for x, means that 0 is less than 6, which is true. 0 is less than 6, so 0, 0 is a solution. So I'm going to shade towards 0, 0. So, all of the solutions for the blue inequality, the first inequality, are going to be down here below. And all the solutions for the second inequality, the red inequality, are going to be down below it too. But I only need those points that are going to work for both. And since the two arrows are pointing at each other in here, the two sets of arrows are pointing at each other in here, these are going to be the points that are solutions for both. Okay? I can't come out here because those are solutions for the first inequality, but not for the second. And I can't come out here because those are solutions for the second inequality, but not the first. So I need all of these points in here, and those points should satisfy both inequalities. You can always choose one and check it. 3, 0, or sorry, 3, well, yeah, 3, 0 would work to check for both of these. And I'll do this real quick for just this one. 3, 0. Plug in 0 for y, 3 for x into both inequalities. Right? In the first one, we get 2 times 3 is 6. 6 minus 2 is 4. 0 is less than 4 is true. -3 plus 6 is 3. 0 is less than 3 is true. So those are your solutions to both. And that's it. That's all there is to it. So find out where the solutions are to each one individually, and then go and then find out where those two places overlap, and those are going to be solutions to both inequalities. Okay? All right, now you try one. Try this guy, stop the video, give it a shot, start it back up, and see if you're right. All right. So I didn't realize I was doing all of that while the video was still rolling, but there you go. That's how you're going to graph those two lines. Now, check for 0, 0 to see if it's a solution in each. And for y is greater than 5, it's not, so we got to shade up. For y is less than or equal to negative 2x plus 6, it was a solution, so we got to shade towards the 0, 0. Now, where are these two sets of solutions going to overlap? Well, they're going to overlap right in here, and this is where you want to shade in your graph, okay? I don't want you to shade the whole grid, right? Don't shade the blue line individually and then the red line individually and then try to reshade the place where they overlap. Just use these little arrows. It keeps the graph looking nice and neat, okay? All right. Another one for you to try. Stop the video, start it back up, see if you're right. And that's what your graph should look like. Does yours look like that? Okay. We've got some more to try here, but just graphing the lines. Obviously, the first one's going to be a solid line because it's equal to. Second one's going to be a dotted line because it's not equal to. I checked my solution. I checked my 0, 0 point down here to see if it was a solution for these guys, and it was a solution for both of them. So I was going to shade each individual one towards 0, 0, and so that's where the overlap came from. Okay. Another one for you to try. Give it a shot. Okay. Just to give you a nudge here, we're going to have to get this in slope-intercept form. So we're going to do a little bit of prep work before we can go graph. So stop the video, give it a shot, and see what you come up with. And there you have it. Is this what you came up with? When you solve down, or when you get to slope-intercept form, you should have y is less than 2/3 x plus 2, and then y is greater than or equal to 5/3 x minus 1. And by the time you find the solutions to both inequalities, and then you look where those solutions intersect, overlap, that's going to be your solution to the system. Okay? Hopefully we're getting this. If not, make sure you come see me. Okay? I got a couple more that I'll show you. So here's what you needed for number 5 to fill in the 6 and the 5. And I'll go ahead and show you number 6. You're filling in the 6x and the 4. So go ahead and do both of those. I'll show you those graphs, and then we'll move on to writing the equations. Okay? Okay. Here's what number 5 should look like. Right? When you get this into slope-intercept form, you should be into this right here. Y is less than or equal to negative 1/2 x plus 3. And then for the second one, you should get y is less than or equal to 1/2 x minus 5/2. Now, the blue line over here is the one that corresponds to the second inequality. So how do you graph that when the y-intercept is negative 5/2? Well, negative 5/2 is basically negative 2.5, right? So our first point needs to go on the y-axis, and it needs to be at negative 2.5, which is about right there, about halfway in between negative 2 and negative 3, right? And then when you count your slope, which is up 1, right 2, we would go up 1 to be right here, and then right 2, oh wait, sorry, up 1, which would be right here, and then right 2, which puts you right there. So you're still going to be in between two grid lines, halfway, okay? And that's how you would go about graphing that, in case it's been a while since you've seen a fraction when you're trying to graph as far as a y-intercept goes, okay? But they're both going to be solid, and we do your 0, 0 check, and you should find that the solutions for each are going, for both of those guys are going to overlap down here at this bottom section. Number 6, the graph should look like this. Now you have two parallel lines, okay? And the solutions for each parallel line are both going to be under the line, okay? 0, 0 worked for the first inequality, but not for the second. So the points in here are not going to be solutions to the system because although they work for the red line, they don't work for the blue line. So the only solutions, the only points that are going to work for both are these guys that are below the blue line here. Okay, so that's why we're shading all the way under the second line. Okay. Again, hopefully this is making enough sense. If not, make sure that you come find me. Okay. All right. Now we got to be able to write the equations, write the inequalities from graph. All right. So let's try to do that here for number 7. Here's your graph. Now here's what we know. We know that we can write this in slope-intercept form. So we got to find the slope and we got to find the y-intercept. And there are going to be some inequality signs. Okay? Now, if you want, we can make this guy inequality 1 and this guy inequality 2. It doesn't matter which way it goes. So inequality 1 is going to be equal to, because it's a solid line, the y-intercept is down here at -3, so this is going to be -3, and then the slope, right? The slope we have to count from one street corner to the next, which is down here. We have to go down 1, right 2. Down 1 is negative, right 2 is positive, so -1 over 2, so -1 half is going to be your slope. Now, is it going to be greater than or less than? Well, 2 ways you can look at this. You can check to see it. I mean, 0, 0 is supposed to be a solution for the red line because we're shading towards 0, 0, right? This gray part means that we're shading all above 0, towards 0, 0 for that line. So you could go plug in 0, 0 and see which way this is supposed to go to make 0, 0 true. So 0, 0 minus 3. We get 0 here and -3 here. And the inequality sign that makes this true is greater than. So it's going to be y is greater than or equal to -1/2 x minus 3. The other way you can look at this, and it might be a little quicker, is that the shaded area for the solution for both of these is above the red line. So y has to be greater than. Okay? Same thing for the second one. We know it's not going to be equal to because it's a dotted line. Now, our y-intercept is here. So it's at 0, touches the y-axis at 0. So you could put in a +0 here if you want, just to keep the process going. And then the next place where it crosses a street corner is here. So we have to go up to right 1. Up to right 1 gets us a slope of 2 over 1. Okay? Now the problem with checking 0, 0 for this line is that it goes through 0, 0. And so that's not going to help us very much if we check 0, 0. So what we're going to have to do is we can choose a different number, and since the shaded area is over here, any point that's over in this area should be a solution for the blue line. So we could go check 1, 0, which would be about right there, and that would be okay. So we got to plug in 1, 0, which means 0 for y, 1 for x, and we get 0 on the left side and 2 on the right side, and the inequality sign that makes that true is less than, because 0 is less than 2. So this is going to be less than. Another way to look at this is that the blue line here, the shaded area that's the solution, is below that blue line, so y has to be less than. Okay? But here are your 2 inequalities that you need to come up with for that system. Okay? All right. Try it for this guy. Stop the video, come up with your inequalities, and see if you come up with the same one I did. Okay, did you come up with those 2 inequalities? Okay? Now, the blue line is my first inequality. I know that the y-intercept is +2. That's why we got a +2 here. The next street corner it hits is if you go up 3, right 1, so that's your slope. 3 over 1x, or just 3x. And then we've got to figure out it's not equal to because it's dotted. And then we got to figure out if it's greater than or less than. And I checked 0, 0. 0, 0 should be a solution for the blue line because your solutions are all down here towards on the 0, 0 side of that line. So I plugged in 0, 0 and got 0 and 2. 0 on the left-hand side, 2 on the right-hand side. And the inequality sign that makes that statement true is less than. And so we have to put less than into the inequality. So y is less than 3x plus 2. Same thing for the red line. The y-intercept is negative 4, so we got minus 4 out here. The next street corner is if you go up 1, right 2, so the slope is 1 over 2. I know it's going to be equal to because it's a solid line. And then I come down here and I plug in 0, 0. 0, 0 is not supposed to be a solution for the red line because the shaded area is away from 0, 0 for the red line. So when I plug in 0, 0, I need an inequality sign that will make this false. So 0 minus 4 is negative 4, so 0 on the left-hand side, negative 4 on the right-hand side. The inequality sign that makes that false is greater than, so I put a greater than, so it's going to be greater than or equal to. And those are your two inequalities, okay? Got one more to try. Give it a shot. See what you come up with. And there are your two inequalities for this one. Okay? I didn't check 0, 0 for these. You could. Keep doing that and see if we can't get that to make sense. But the shaded gray part right here, the purple that's been circled, is above the blue line. So the first equation's got to be greater than, and below the red line, so the second equation's got to be less than. That's how I determined the signs. Okay, and if that makes enough sense, then you can keep using that. They're both going to be not equal to because they're both dotted lines. And there you go. Okay. Any issues there, again, come find me, and we can definitely go over it some more and see if we can't make it make sense. Right? Homework's out in Canvas. Make sure you have that done by next class.